Josh White with JW Math Tutoring here. I want to go through one of the problems from my June 2025 worksheet series. Basically, it's worksheet number 2, problem number 3. And the reason I want to just briefly go through this problem again is because it appears that probably some of the numbers that were reported, in the source where I got this problem from were incorrect. So the original version of the problem, the version of the problem you see in the video, is the one listed at the top here where it says original. In other words, those are the coordinate values for point B. However, several commenters pointed out those are most likely incorrect, and the reason is because if you graph that point out, that point is not actually on the unit circle. So, for example, here is a visual representation of what I'm talking about. So I've graphed that point out. 4 over root 97 comma negative 6 over root 97. You can see it right there. Okay? Just gives you the decimals. Now, I've also graphed out the unit circle. Basically a circle centered at the origin with a radius of 1. Okay, so you can clearly see that it is not on the unit circle. However, I don't think that necessarily causes an issue technically in terms of the angle measure or finding the answer, because the method I used to find the answer was still to draw the angle and then use opposite over adjacent for finding the tangent of it. So for example, you have your point here at 1, 0, you have your point here at the origin 0, 0, okay, and then down here you have the third point. So if you connected them, like this, even though this point is not actually on the unit circle, if you're going to find the measure of this angle right here, you'd still follow the same approach. In other words, even though this point's not on the unit circle, the answer, as the original one, as I showed you, would still be negative 3/2 or negative 1.5, because the tangent of this angle here is just the opposite, which would be this, this value over the adjacent. The opposite is going to be your y coordinate. The adjacent is going to be your x coordinate, horizontal distance here. So in the original version, the approach is the same. The answer is the same for those given numbers, but I guess the key takeaway is those are most likely not numbers that you would be given, since again this point is not on the unit circle. So I've corrected it. I've updated the numbers to what I think they should be. So basically, most likely the numbers were intended to be, say, 4 and 9, or specifically negative 9, as compared to 4 and negative 6. The reason being, if you take 4 squared plus negative 9 squared, you get 16 plus 81, and notice that equals 97, which is equal to the number divided on the bottom. In other words, if you set up a right triangle, or you set up a right triangle, you'll get 4 and 9 and root 97, as your three sides. So just to show you, I've corrected it, like I said, in the worksheet, and then just to show you, how you would get the answer for these values. So it's the same basic thing, right? Here's point A at 1, 0. Here is the origin at 0, 0. And then down here is point B, the 4 over root 97, negative 9 over root 97. Notice it's not drawn to scale because the horizontal distance should be actually like less than half of the vertical distance. So it actually should probably be something like whatever, way down here. But just ignore that for right now. So the point is, we trace out this angle. Okay, then we've got this angle here, which is, has a measure W radians. We take the tangent of this angle, and again, it's the same basic idea or same basic procedure. The opposite value here is your y coordinate, which is your negative 9 over root 97. And then your adjacent value, your horizontal distance, your x coordinate, the 4 over positive root 97. So tan W would just be equal to opposite over adjacent. This you could technically plug into Desmos, but what's going to happen is the root 97s will each cancel out with each other. So you get negative 9 over 4. You could enter that as a correct answer, or you could enter its decimal equivalent of negative 2.25 as well. All right, so just repeat, the corrected version of the problem will be what's on the worksheet that you see going forward. And thank you to the multiple commenters that pointed out the issue with the numbers chosen for this problem. Anything else, any other questions or comments, whatever, you can obviously feel free to leave them on this video, but most likely it's better to leave it on the main, worksheet number 2 video as well.